In section 1, we're going to be looking at properties of exponents. So you should have on your note sheet already filled in all of the properties for exponents. So let's talk through those real quick. If we have the same base, so one condition is that we have to have the same base. So if we have x to the m times x to the n, we add those exponents. So when we have two exponents being multiplied, they get added. And the second one, when we have an exponent raised to another exponent, those get multiplied. So x to the m to the n would be x to the m times n. If we have a product inside parentheses with an exponent, that exponent gets applied to both of those bases. A negative exponent, so a negative exponent just tells us that we are dividing by that number, whatever the exponent is, times. So when we have x to the m, that means we're multiplying x m times. So x to the negative m is just telling us to divide by x that many times. So the way that we'll see this often is if we have a negative exponent, we will either move that from the top of a fraction to the bottom to make it positive, or if a negative exponent is in the bottom of a fraction, we move it to the top of that fraction to make it positive. Any base to the 0 power is 1. And then when we're dividing exponents, so x to the m over x to the n, we subtract those. And that base is going to end up on top or bottom wherever we have more. So if there's x to a greater number on top, you're going to have that base on top. If there's more on the bottom, you're going to end up with that base on the bottom. And then again, if we have two things being divided inside of some parentheses, that exponent gets applied to the top and the bottom of that fraction. So let's look at the examples that you have there to work through. So the first one is x to the 5th times x to the negative 8th times x to the 6th. To simplify that, all we have to do is combine those into one base, and we are adding those exponents across. So 5 plus a negative 8 plus 6. So 5 minus 8, negative 3 plus 6 is x to the 3rd. Is as simple as we can make that, because we don't know what x is, so we can't assign any value to that. So x to the 3rd is as simple as that one gets. Example B, we have c over d to the negative 4th to the negative 2nd. First thing I would do here is note that c is really c to the 1st. When we have something to the 1st power, we don't write that 1st power, but we need to know that that's there. So we have a fraction raised to an exponent. That negative 2 gets applied to each of those, and so we have an exponent raised to an exponent. So on top we have c to the 1 times negative 2, and in the bottom of that fraction, in the denominator, we have a negative 4 times a negative 2. So we multiply negative 2 into each of those exponents. That will give us c to the negative 2 over now d to the positive 8. And since we have c to a negative exponent, that's the same as dividing by c squared. So that c to the negative 2 would move to the bottom and become positive. And we have d to the 8th. And we can't just leave the numerator of that fraction blank. We still have to have something there. I guess one way to see that is we really have 1 c to the negative 2. And so if that c to the negative 2, if we move that down, we still have that 1 in the numerator. So we can't just leave that empty. We have to have something there. Moving on to the last example in this part, a to the negative 3rd, b to the 4th, over a to the 5th, b. So again, might be useful to note that we have b is b to the 1st. And we're going to take care of each of these variables separately. So let's look at a. And I think the way that, or maybe one way to do these that's simplest is first move things so that we don't have any more negative exponents. So the only thing that would move is a to the negative third. We would maybe want to move that down so that we have a to the third, a to the fifth, b to the first in our numerator. So now it's pretty clear where the a's will end up. We have a to the third times a to the fifth in the denominator. And so that's going to give us a to the eighth because we have an exponent times an exponent, so we add those in this case. So we have a to the eighth in the denominator. And for the b, what I think is useful to look at is where do we have more. So we have b to the fourth on top, b to the first on the bottom. We have more b's on top, so we know b is going to end up on top. And when we're dividing, we subtract. So we have b to the 4 minus 1, which is b to the third. And that's as simplified as we can make that one.